in this relationship, we're relating that a plane's altitude, that's our dependent variable, versus the time it's flying. Okay, so it looks like here at 30 minutes in the flight, it's at 6,750 meters, and at 50 minutes it's gone down, and it looks like it's slowly descending or losing altitude. Okay, so we can graph this. We're going to graph our altitude in meters on the y. We're going to graph time in minutes along the x. Okay, and then so let's maybe make that about, I'm just going to maybe move this over a little bit just to make it a little bit easier to show my scaling. So the altitude I'm going to make about 7,000 right here, and for minutes let's make that about 100. 50 minutes here, 40, 30. Okay, so we got 60, 70, 80, 90, and then 110 right there. Okay, so we can divide this up into sevens. So the 7's an awkward number to divide things into, so I'm going to have a little bit of a hard time. It's a little bit more like that. So 6, 5, 4, 3, 2, 1. Okay, so there's 1,000 meters. Okay, 2,000, 3,000, 4,000, 5,000 is right about there. Okay, so at 30 minutes, we know that the altitude is 6,750, so right about there. Okay, and again, your axes don't have to be perfect, but you just want to try to scale them reasonably. At 50 minutes, it's at 5250, so maybe somewhere around here. At 90 minutes, the altitude is going to be 2,250, so maybe somewhere around here. And we know that this should kind of line up in a straight line. And at 110, 750 is maybe somewhere around there. Okay, so it looks like my scaling's okay. So my linear pattern is going down in a straight line, kind of like that. And eventually it's going to hit the ground or land. So what is the altitude at 150 minutes? Well, if I kind of use my slope, and I can use my slope as my progression because it's my rate. So I know that it goes plus 20, it goes minus 1,500 meters. Okay, so I've gone down 1,500 meters. So 5250 minus 6,750 is going to be minus 1,500 meters. So I'm going down 1,500 meters for every 20 minutes. So if I do another 20 minutes here, that gets me to 130 minutes. And I'm going to go down, I'm going to be negative 750 meters. So we've kind of hit the ground. It looks like that's the case as well when we look at the graph. At 150 minutes, we're underground. And so if I were to continue this pattern, add another 20 minutes to 150 minutes, we're going to be even further down into the ground. So negative 2250 meters. Okay, which is really impossible. But based on the pattern, yeah, that's going to be my altitude at 150 minutes. It looks like I crashed well before then, though. So how does the slope tell you that the plane is descending rather than ascending? Well, the slope is going to be negative. So when I calculate my slope, my change in my y over my change in the x, so if I take those two coordinates, it's between 50 and 90. Okay, my change in the y is going to be positive 40. Okay, here my change in the x is minus 3,000. Okay, and if I my change in y, and if I do my subtraction in the right order, I should get the same number. And I can see that the slope is negative. So it's going to be plus 40 minutes. Okay, so when I calculate the slope, okay, the change in y over the change in x, it's going to be the end position was 2250 minus 5250. My change in the y is negative 3,000 meters. Okay, the change in the x was going to be at 90 minutes minus 50 minutes, which is positive 40 minutes. Okay, and when I work out this slope, this slope is going to be negative, and we can work out the unit slope if you like. This is going to be, it looks like it's negative 750 meters per minute. Okay, and that's the unit slope, and the negative indicates that it is descending rather than ascending. It's going down versus going up.